Okay, today we're looking at 2.8, which is titled the wow factor. So we're doing more factoring. This time though, we have trinomials, so meaning most of the things we're looking at are 3 terms, but there's going to be a number up front. So a is not just 1. So let's start off, there's a little bit of like a task for us to go through. So it says, because she has such a great business manager, Optima offers her customers a lot of options. One option is to have rectangles that have side lengths that are more than 1. For instance, Optima made this cool block. And we want to write 2 equivalent expressions here. So here, notice we've got our x squared and we've got our x squareds. Our rectangles are our x's, right? And we've got a unit 1. If I think about the area inside then, I'd have x squared plus x squared plus x plus x plus x, right? Plus 1. So this is the same as 2x squareds plus 3x plus 1. If I wanted to think about the outside of it though, this side length is x plus 1. Notice this side length is x plus 1. So that's the same as 2x plus 1. So thinking about the area then, we would multiply 2x plus 1 times x plus 1. And we're saying, hey, these 2 expressions are equivalent. If we wanted to double check it though, do you remember how we would distribute? So we'd do like the 2x to both of them and then the 1 to both. So we'd have 2x times x, which is 2x squared. 2x times 1 is 2x. 1 times x is x, and 1 times 1 is 1. So we do end up with 2x squared. 2x plus x is 3x plus 1. So it does work. So this is us checking. Those are equivalent. So here we have some partial orders, and we have one of the expressions for the area of the block, and we know length of one of the sides. Use a diagram to find the length of the other side and write a second expression for the area of the block. Verify your 2 expressions for the area of the block are equivalent using algebra. Okay, so this side we have, one side, so we got a rectangle, and we've got a length of x. Okay, so this is the length of x. We know we have plus 3. So this is then going to be 3. Okay. So here we want to have 2x squareds. So we're going to have 1x. And we've got to have another x to make the 2x squareds, right? Because this is now x squared, and so is this. Okay, now let's see. We want a total of 7 x's. So this is x. So is this. So we already have 6 x's. So I actually just need 1 more. So I maybe have drawn this a little bit too long on the right side. Because technically here I just need 1 more rectangle and I'd have my last x. So hey, this 1 more side, if I now complete it, this rectangle, it looks... Okay, now I have 7 x's and I do have 1, 2, 3 left over. Okay. So, as we look at the 2 sides then, on this side I have x plus x is 2x plus 1. So we're saying, okay, 2x plus 1, sorry, I'll write down here where it says equivalent expression for area. 2x plus 1 is one of the sides, times x plus 3 is the same as what we have. Okay, so let's go through. I'm actually going to show you a new way to multiply. If you like distributing, keep doing that. Like, do your little arrows, that's great. But another way to keep your work organized is you could actually set it up like the box. And we'll always have a 2 by 2 because we have a 2x plus 1 times x plus 3. So now just multiply the 2 sides. 2x times x is 2x squared. 1 times x is x. 2x times 3 is 6x. And 1 times 3 is 3. So now as you add that together, you have x squared. X plus 6x is 7x plus 3. And notice it's really similar to our diagram. It just has all numbers in it rather than like the blocks. Okay, let's look at this next one. This one has a side length of x plus 1. So over here, you can think about drawing our rectangle. We're going to have x plus 1. And I have a total of 5x squared. So that means there's got to be 1, 2, 3, 4, 5x squareds, right? 1, 2, 3, 4, 5. So let's see. Maybe I'll write this actually just as like a 5x. So we know it's all adding together. Okay, let's see how many x's we now have. We have 1, 2, 3, 4, 5, but I need 3 more. So it means there's got to be 3 on this side. 1, 2, 3. X, X, X. I now have 8, and do I have 3 ones? I sure do. So this is going to be plus 3. So the equivalent area would be x plus 1 times 5x plus 3. And you could flip-flop that, do like 5x plus 3 times x plus 1. That's totally fine. Okay, let's check it by multiplying. If you like distributing, you can keep doing that. If you think this box kind of helps you organize your thoughts, then I think that's good too. So one side is x plus 1. The other side is 5x plus 3. So now we multiply what's on each side of the box. 5x times x is 5x squared. 5x times 1 is 5x. X times 3 is 3x. And 1 times 3 is 3. So now let's add it together. 5x squared. 5x plus 3x is 8x plus 3. Okay. So in these problems, remember you should always look for a greatest common factor, right, a GCF, before beginning to factor your trinomial. These ones are going to have 3 terms. Remember, sometimes there's that middle term missing. I'll put a 0 in for it. And there's going to be a number out front. Okay. So you can draw the area models like we did there. The nice thing is they kind of gave us the sides there, right? They gave us one of the sides. You're not always going to know that, but the same process that we did last time works. So rearrange it into standard form. We're going to find 2 numbers that multiply to AC, okay? A and C, remember, are the numbers in front of x squared and the constant at the end, and add to B, which is the term in the middle. We're going to rewrite the middle term of those 2 numbers, which is what we did last time. This time, though, we're going to factor by grouping. There's no shortcut here. So that's the biggest thing to remember. We can't use a shortcut. So remember, you first multiply the leading coefficient, A, the number in front of x squared, with the constant C, the term without a variable. I like to call this the magic number. So 3 times negative 8 is a negative 24. Maybe I should recognize 3x squared plus 10x minus 8. There's no GCF there, right? I can't take 3 out of every term. And the only things that multiply to 3 up front are 3 and 1. Okay, we're looking to add to 10. So maybe you try something, you're like, oh, negative 6 and 4. Oh, but the problem with that, 6 and 4 do give me 10, but one's got to be negative, one's got to be positive, so we got to try something out. What if I did like 12 and 2? 12 times 2 is 24, and if I want 1 to be negative, if I make it negative 2, 12 plus negative 2 is 10. Okay, great. So we're going to go ahead and we're going to rewrite this 10x, right? Maybe I'll even do it in different colors so you kind of remember what's going on. The 10x we're going to write as 12x minus 2x, okay? The negative 8 at the end doesn't change, but now I'm going to do my grouping. So the GCF of 3x squared and 12x is a 3x, so divide both of those terms by 3x. 3x squared divided by 3x is x, 12 divided by 3 is 4, x divided by x is just 1, so that's x plus 3, x plus 4. There's a 3x out front. Okay, the GCF here, we are going to pull out the negative. So it's going to be a negative 2, I think is an F, right? Because 2 and 8, you can pull 2 out of both. I'm going to write the GCF out front. Negative 2 divided by negative 2 is 1. And then we'd have the x, so 1x. You can write 1 if you want. Negative 8 divided by negative 2 is 4. So now, we're going to pull out the common factor, which is x plus 4. And put the leftovers 3x minus 2 in parentheses. If you want to double check your work, right, you can go back through and multiply it out to double check that it works. Okay, let's do it again. So we've got 2x squared plus 8x minus 5. Is there a number we can pull out of all those? 2, 9, and 5? I don't think so. So we're going to set it up. We're going to say we're going to find the magic number. 2 times negative 5 is a negative 10 and adds to 9. 10 and negative 1 multiply to negative 10, but 10 plus negative 1 add to 9. If I go too quick on those, feel free to pause and think about it yourself before you look at the answer. So now we're going to go ahead and we're going to rewrite the middle term of 2x squared plus 10x minus 1x minus 5. So we wrote the 9x as 10x and negative 1x, right? Because 10 minus 1 is 9. Now we do our grouping. The GCF of these first two is a 2x. The GCF of this next one is a negative 1. So I'm going to write the GCF out front. 2x squared divided by x is x. 10 divided by 2 is 5. X divided by x is just 1. Okay, a GCF of negative 1. When I divide a negative by a negative, I get a positive x. When I divide a negative 5 by a negative 1, I get a positive 5. So therefore, I get x plus 5, and the leftovers of 2x minus 1 are the other part. Okay, let's look at the next one. 9, 42, and 24. Those numbers are quite big, right? I can't divide everything by 9, but what else multiplies to 9? 3. Can I take a 3 out of each of those? Let's see. If I divide each of these by 3, I get 3x squared. 42 divided by 3 is 14x, and then I have plus 8, so it does. But right now it's not equivalent. Remember, you do need to still write that 3 out front. We will keep the 3 out front, but a nice little part here is now I'm just doing, to find my magic number, I'm doing 3 times 8 is 24 and adds to a negative 14. So these numbers end up being a bit smaller, right? And they're easier to work with. So here, both of these are going to have to be negative to get a positive and then add to a negative. So what multiplies to 24? 8 and 3, but that would give me negative 11. 6 and 4, but that gives me negative 10. What about 12 and 2? That seems to work. Okay, I'm going to write the 3 out front still. That's not going to change anything. But we're going to rewrite the middle as a negative 12x minus 2x plus 8. Okay, now we're going to do our grouping. The GCF of these first two is 3x. The second two is negative 2. There's still a 3 out front. I'll maybe do like some big parentheses so we can just worry about the inside for a minute. We've got 3x. When I divide 3x squared by 3x, I get x. Negative 12 divided by 3 is negative 4. X divided by x is just 1. We're going to write our GCF of negative 2. Negative 2 divided by negative 2 is 1, so we're just left with x. 8 divided by negative 2 is negative 4. So here we will have the 3 out front still, but our two sets of parentheses are x minus 4 and 3x minus 2. Okay. On this next one, 8 and 18. Oh, I feel like they can at least both have a 2. Is there anything bigger? 4? Nope. Okay, so let's divide both of them by 2. So we'd have 2, and then we have 4x squared minus 9. So remember these ones, we did things similar like this last time. Notice how there's no middle term? Do you guys remember what we did last time? If there's nothing in the middle, we could say there's 0x. So this time we're saying, okay, negative 9 times 4 is negative 36, but it adds to 0. Can you guys think of any numbers that when you multiply to negative 36, you add to 0? You got a negative 6 and a 6. So then we get 4x squared minus 6x plus 6x minus 9. Okay, so let's do our grouping. Here we'd have a GCF of 2x. Here we'd have one of 3. So we get 2x. And what do we get when you divide both those terms? We get 2x minus 3. Then we have plus 3. And we have a 2x minus 3. So our final answer is 2 times 2x minus 3, 2x plus 3. Okay, let's look at the next one. 2, 17, and 9. So I don't think there's any GCF there, so we're saying what multiplies 2 times negative 9 is negative 18, adds to negative 17. I like these ones because negative 18 and 1, right, you know it's got to be really close to that negative 18. Okay, so we're going to have 2x squared minus 18x plus 1x minus 9. Do our GCFs. We got a 2x here. 1x and 9. So this is a little tricky. When you notice like, hey, they don't really have anything in common, we actually just pull out the number 1 because we still need a placeholder there. It's not 0, but we'll just divide everything by 1. Okay, we write the 2x out front. When we divide both terms by 2x, we get x minus 9. We'll write our GCF of 1, and we also get an x minus 9. So the final answer here is x minus 9 times 2x plus 1. Okay. I want you to try at least this next one and see what you come up with. So now, if we want to go through it together, the first thing I would notice here is you got a 12x, a 10x, and a 2. You're going to make life a lot easier and divide everything by 2. So we'd have, this is the same as 2 times 6x squared plus 5x plus 1. So we're saying what multiplies to 6 and adds to 5. Be careful, you may be tempted to do like 6 and negative 1, but that's going to multiply to negative 6. So here you actually get 2 and 3. So we're going to have 6x squared plus 2x plus 3x plus 1. Okay, so then we get 2. Oh, sorry, I got to do our grouping. Okay, GCF of these first two is a 2x. 3x and 1 doesn't have one, so we just say it has a GCF of 1. So I shouldn't say it doesn't have one, it has it just of 1. So you get 2x. When you divide both terms, you get 3x plus 1. Plus 1 is the GCF there. You also have 3x plus 1. So the final answer is 2. 3x plus 1 times 2x plus 1. Okay. One more here. 49 times 9. This is one where you may need to grab out a calculator, right? 49 times 9. Nothing they both divide by, but we get negative 441. And since there's no middle term, I'm saying it adds to 0. Okay, this is one of those ones where, hey, it's got to be the same number on both sides, right? One's negative, one's positive. This one is a little tricky, but you end up getting 21 on both sides. So you'd have 9x squared minus 21x plus 21 minus 49. Okay, do our grouping. This has a 3x. Oops, I missed an x here. Give me 1 second. And then 21x minus 49. This one can be divided by 7. Okay, so 3x, and what do we get when we divide? We get 3x minus 7 plus 7. We also get 3x minus 7. So here you have 3x plus 7 and 3x minus 7. All right, good.